Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. For those who have farmlands, a drip irrigation system might be the best system for you to irrigate your plants. While for those who have backyard farming, maybe hydroponics will work for you. Drip irrigation is sometimes called trickle irrigation and involves dripping water into the soil at very low rates, around 2 to 20 liters per hour, from a system of small diameter plastic pipes filled with outlets called emitters or drippers. Water is applied close to plants so that only part of the soil in which the roots grow is wetted, unlike surface and sprinkler irrigation, which involves wetting the whole soil profile. With drip irrigation water, applications are more frequent, usually every 1 to 3 days, than with other methods, and this provides a very favorable high moisture level in the soil in which plants can flourish. Now, the suitable crops. Drip irrigation is most suitable for row crops, vegetables, soft fruit, tree, and vine crops, where one or more emitters can be provided for each plant. Generally, only high-value crops are considered because of the high capital cost of installing a drip system. Suitable slopes. Drip irrigation is adaptable to any farmable slope. Normally, the crop would be planted along contour lines, and the water supply pipes or the laterals would be laid along the contour also. This is done to minimize changes in emitter discharge as a result of land elevation changes. While for suitable soil, drip irrigation is suitable for most soils. On clay soils, water must be applied slowly to avoid surface water ponding and runoff. On sandy soils, high emitter discharge rates will be needed to ensure adequate lateral wetting of the soil. Suitable irrigation water. One of the main problems with drip irrigation is blockage of the emitters. All emitters have very small waterways ranging from 0.2 to 2 mm in diameter, and this can be blocked if the water is not clean. Thus, it is essential for irrigation water to be free of sediments. If this is not so, then filtration of the irrigation water will be needed. Blockage may also occur if the water contains algae, fertilizer deposits, and dissolved chemicals which precipitate such as calcium and iron. Filtration may remove some of the materials, but the problem may be complex to solve and requires an experienced engineer or consultation with the equipment dealer. Drip irrigation is particularly suitable for water of poor quality or saline water. Dripping water to individual plants also means that the method can be very efficient in water use. For this reason, it is most suitable when water is scarce. Drip emitters release water to your plants from the mainline tubing. The emitters can be punched directly into the mainline or inserted into the end of a length of 1/4 inch tubing for plants that aren't close to the mainline. This is the most practical way to emit water to your plants when they aren't evenly spaced. Now, looking at the picture at the bottom right, you can see an emitter with several capacities. The black can give out 1 gallon per hour, the green can give out 2 gallons per hour, while the red can give out 4 gallons per hour. A typical drip irrigation system consists of the following components: the pump unit, control head, main and sub-main lines, laterals, emitters or drippers. Now, the pump unit takes water from the source and provides the right pressure for delivery into the pipe system. Now, the control head consists of valves to control the discharge and pressure in the entire system. It may also have filters to clear the water. Common types of filter include screen filters and graded sand filters, which removes fine material suspended in the water. Some control head units contain a fertilizer or nutrient tank. These slowly add a measured dose of fertilizer into the water during irrigation. This is one of the major advantages of drip irrigation over other methods. Main lines, submains, and laterals supply water from the control head into the fields. They are usually made from PVC or polyethylene hose and should be buried below ground because they easily degrade when exposed to direct solar radiation or sunlight. Lateral pipes are usually 13 to 32 mm in diameter. Emitters or drippers are devices used to control the discharge of water from the lateral to the plants. They are usually spaced more than 1 meter apart, with one or more emitters used for a single plant such as a tree. For row crops, more closely spaced emitters may be used to wet a strip of soil. Many different emitter designs have been produced in recent years. The basis of design is to produce an emitter which will provide a specified constant discharge which does not vary much with pressure changes and does not block easily. Hydroponic is a type of horticulture and a subset of hydroculture, which is a method of growing plants, usually crops, without soil, by using mineral nutrient solutions in an aqueous solvent. Terrestrial plants may be grown with only their roots exposed to the nutritious liquid. Or, in addition, the roots may be physically supported by an inert medium such as perlite, gravel, or other substrates. Despite inert media, roots can cause changes of the rhizosphere pH, and root exudates can affect the rhizosphere biology. The nutrients used in hydroponic system can come from many different sources, including, but not limited to, fish excrement, duck manure, purchased chemical fertilizers, or artificial nutrient solutions. Plants commonly grown hydroponically on inert media include tomatoes, peppers, cucumbers, strawberries, lettuces, marijuana, and model plants like Arabidopsis thaliana. Hydroponics offers many advantages, one of them being a decrease in water usage for agriculture. To grow 1 kilogram or 2.2 pounds of tomatoes using intensive farming methods require 400 liters or 88 gallons of water. Using hydroponics, you use only 70 liters and only 20 liters for using aeroponics. Since it takes much less water to grow produce, it could be possible in the future for providers in harsh environments with little accessible water to grow their own food. Aquaponics refers to a food production system that couples aquaculture, which means raising aquatic animals such as fish, crayfish, snails, or prawns in tanks, with hydroponics, cultivating plants in water, in a symbiotic environment whereby the nutrient-rich aquaculture water is fed to hydroponic-grown plants involving nitrifying bacteria for converting ammonia into nitrates. As existing hydroponic and aquaculture farming techniques form the basis of all aquaponic systems, the size, complexity, and types of food grown in an aquaponic system can vary as much as any system found in either distinct farming discipline. Substrates or growing support material. Expanded clay aggregate is one of them. Baked clay pellets are suitable for hydroponic systems in which all nutrients are carefully controlled in the water solution. The clay pellets are inert, pH neutral, and do not contain any nutrient value. The clay is formed into round pellets and fired in rotary kilns at 1200 degrees Celsius. This causes the clay to expand like popcorn and become porous. It is light in weight and does not compact over time. The shape of an individual pellet can be irregular or uniform depending on brand and manufacturing process. The manufacturers consider expanded clay to be an ecologically sustainable and reusable growing medium because of its ability to be cleaned and sterilized, typically by washing in solutions of white vinegar, chlorine bleach, or hydrogen peroxide and rinsing completely. Another view is that clay pebbles are best not reused even when they are clean due to root growth that may enter the medium. Breaking open a clay pebble after a crop has been shown to reveal this growth. Grow stones, made from glass waste, have both more air and water retention space than perlite and peat. This aggregate holds more water than parboiled rice hulls. Grow stones by volume consist of 0.5 to 5% calcium carbonate. For a standard 5.1 kilogram bag of grow stones, that corresponds to 25.8 to 258 grams of calcium carbonate. The remainder is soda lime glass. Perlite, on the other hand, is a volcanic rock that has been superheated into very lightweight expanded glass pebbles. It is used loose or in plastic sleeves immersed in the water. It is also used in potting soil mixes to decrease soil density. Perlite has similar properties and uses to vermiculite, but in general holds more air and less water and is buoyant. Coconut coir. Regardless of hydroponic demand, coconut coir is a natural byproduct derived from coconut processes. The outer husk of a coconut consists of fibers which are commonly used to make a myriad of items ranging from floor mats to brushes. After the long fibers are used for these applications, the dust and short fibers are merged to create coir. Coconuts absorb high levels of nutrients throughout their life cycle, so the coir must undergo a maturation process before it becomes a viable growth medium. This process removes salt, tannins, and phenolic compounds through substantial water washing. Contaminated water is a byproduct of this process, as 300 to 600 liters of water per 1 cubic meter of coir is needed. Additionally, this maturation can take up to 6 months, and one study concluded the working conditions during the maturation process are dangerous and would be illegal in North America and Europe. Despite requiring attention, posing health risks, and environmental impacts, coconut coir has impressive material properties. When exposed to water, the brown, dry, chunky, and fibrous material expands nearly 3 to 4 times its original size. This characteristic, combined with coconut coir's water retention capacity and resistance to pest and disease, make it an effective growth medium. Used as an alternative to rock wool, coconut coir, also known as coir peat, offers optimized growing conditions. Parboiled rice husk, or PBH, is an agricultural byproduct that would otherwise have little use. They decay over time and allow drainage, and even retain less water than grow stones. A study showed that rice husk did not affect the effects of plant growth regulators. Vermiculite. Like perlite, vermiculite is a mineral that has been superheated until it has expanded into light pebbles. Vermiculite holds more water than perlite and has a natural wicking property that can drown water and nutrients in a passive hydroponic system. If too much water and not enough air surrounds the plant roots, it is possible to gradually lower the medium's water retention capability by mixing in increasing quantities of perlite. Pumice. Like perlite, pumice is a lightweight mined volcanic rock that finds application in hydroponics. The next is sand. Sand is cheap and easily available. However, it is heavy, does not hold water very well, and it must be sterilized between uses. Due to sand being easily available and in high demand, sand shortages are on our horizon as we are running out. Gravel, the same type that is used in aquariums, though any small gravel can be used, provided it is washed first. Indeed, plants growing in a typical traditional gravel filter bed with water circulated using electrical powerhead pumps are in effect being grown using gravel hydroponics. Gravel is inexpensive, easy to keep clean, drains well, and will not become waterlogged. However, it is also heavy, and if the system does not provide continuous water, the plant roots may dry out. And last, wood fiber, produced from steam friction of wood. It is a very efficient organic substrate for hydroponics. It has the advantage that keeps its structure for a very long time. Wood wool, or wood slivers, have been used since the earliest days of the hydroponics research. However, more recent research suggests that wood fiber may have detrimental effects on plant growth regulators. Now let us discuss about the different types of systems in hydroponics. The first is the wick system. The wick system is the simplest system mechanically, as there are no moving parts or electrical components. This system is not ideal for water-hungry plants like lettuce or tomatoes, as they may use up the nutrient solution faster than the wick can supply it. This system works best for microgreens, herbs, and peppers. Listed below are the project metrics, which shows the working time, the total time, the material cost in US dollars, the equipment and tools that you need, and the materials. You may pause the video to read through this. Now this is the set of instructions of how to construct your hydroponic wick system. As you can see in the drawing, there is a wick, which is actually the cotton or abaca cord as discussed in the slide above. The next is the water culture or raft system. A water culture system is another simple system to set up. In this system, the plants are placed in a styrofoam platform that floats on top of the reservoir with the nutrient-enriched water. Unlike the wick system, you will need to aerate the water in this system. This system is best for growing leaf lettuce, but very few other plants grow well in this system. Please see the project metrics below. Now these are the instructions of how to install your raft system. Based on the picture down below, this time you will have to have an air pump with an air stone. This is used to aerate your water. The next is the drip system, the most widely used type of hydroponic system in the world. Drip systems are simple. A timer controls a submerged water pump that drips nutrient solution into the base of each plant via a small drip line. A recovery drip system collects and reuses excess solution, while a non-recovery system needs a more precise timer to ensure the plants get enough nutrient solution while keeping runoff to a minimum. We'll focus on the non-recovery system to keep it simple. The project metrics are shown below. These are the instructions of how to install your non-recovery drip system, but the picture down below shows a recovery system wherein you have an overflow drain which brings down the nutrient water back to the tank. Another option is the ebb and flow system. An ebb and flow system, also called the flood and drainage system, is slightly more complex in design but is extremely versatile. This system works by flooding the growing medium with a water nutrient solution, then it drains back to the reservoir. Please see the project metrics below. These are the instructions of how to install your ebb and flow system. Try to take note that there is an overflow regulator or a drain tube from your hydroponic plants down back to the reservoir. Next is the nutrient film technique. The nutrient film technique uses a water nutrient solution that constantly flows in a loop from a reservoir through a growing tray where plant roots are suspended in the air and absorb nutrients as the solution flows by. This system makes the ebb and flow system a continuously flowing system, never taking periodic breaks. Please refer to the project metrics below. This is now the instruction set of how to install your NFT or nutrient-free technique system. Try to notice that the plants are now in angle, meaning to say it is going to be naturally draining down to the reservoir. The next option is the aeroponic system. An aeroponic system is a more complex hydroponic method. Plant roots are suspended in air and misted every few minutes with a water and nutrient solution. It is a highly effective method, but one that requires sophisticated pumps and misters. If the equipment malfunctions, the plant roots can dry out and die quickly. Please look at the project metrics below. This is the set of instructions of how to install your aeroponic system. Now let us discuss the growing tips in terms of hydroponics. Most edible plants require at least 6 hours of sunlight each day. 12 to 16 hours is better. Make sure to put your lighting system on a timer so the lights turn on and off at the same time each day. The best lighting for a hydroponic system is a high-intensity discharge light fixture which can include either high-pressure sodium or metal halide bulbs. Halide bulbs emit a more orange-red light which is great for plants in the vegetative growth stage. T5 is another type of lighting used in hydroponic grow rooms. It produces a high-output fluorescent light with low heat and low energy consumption. It is ideal for glowing plant cuttings and plants with a short growth cycle. Ideal temperatures are between 68 and 70 degrees Fahrenheit or 20 and 21 degrees Celsius. High temperatures may cause plants to become stunted, and if the water temperature gets too high, it may lead to root rot. The ideal humidity for a hydroponic grow room is from 40 to 60% relative humidity. Higher humidity levels, especially in rooms with poor air circulation, can lead to powdery mildew and other fungal problems. Consider a humidifier or dehumidifier to adjust the relative humidity. Your grow room should also have an ample supply of carbon dioxide. Your plants will grow faster. The best way to get carbon dioxide to your plants is to make sure that the room has a constant flow of air. If necessary, invest in a fan or air circulation equipment to improve the airflow. Hard water that contains a high mineral content will not dissolve nutrients as effectively as water with lower mineral content, so you may need to filter your water if it is high in mineral content. The ideal pH level for water used in a hydroponic system is between 5.8 and 6.2, which is slightly acidic. If your water doesn't meet this level, chemicals can be used to adjust the pH into the ideal range. And lastly, the nutrients or fertilizers used in hydroponic systems are available in both liquid and dry forms, as well as both organic and synthetic. Use fertilizers that are designed for hydroponic gardening. Do not use standard fertilizers. The fertilizer should have the main macronutrients: nitrogen, potassium, phosphorus, calcium, and magnesium, as well as micronutrients iron, manganese, boron, zinc, copper, molybdenum, and chlorine. I hope you've learned something new regarding drip irrigation and hydroponics. Watch out for my next video. Click the subscribe button to discover all the other videos in this site. Click the notification bell to be notified about new videos that we post. If you have additional comments, please post them down below or at our Arcada Facebook page, and I will answer all your queries. Thank you.